So on question 81, we're asked to answer 4 different parts involving solving equations. So for the first equation, x minus 4 equals 16. Hopefully this is a pretty simple equation to solve. The first thing we want to remember that anytime we're solving an equation, our objective is to isolate the variable. And so in order to isolate the variable on this one, I need to move the 4 to the other side. And to do that, I would add 4 to both sides in order to solve it. Now my variable is isolated, and x equals 20. So that means my solution to this equation is 20, and this would be enough to show or explain how I got my answer. In terms of opening the doors, this would mean I get to open one door, and that door would be door number 20. If I look at the next question, it's asking me to write a linear equation in one variable. So first, this part to me means that one variable means I can only use the same variable, like x. I can use it multiple times, but I can't use an x and then a y. I can only use an x. And I want it to have infinitely many solutions. It also wants me to show the process of simplifying my equation to prove that it has infinitely many solutions. So first, I want to figure out what does this mean to me? What do they want me to do? They want me to create an equation and solve it, and they want it to have infinitely many solutions. So let's look at our flow chart to see what needs to happen in order to have infinitely many solutions. So when I solve an equation, my process is going to be distribute if I can, combine if I can, and then balance. On this equation up here, the only thing I had to do was balance by adding 4 to both sides. Once I do distribute, combine, balance, I should have my answer. And there's 2 options when I have my answer. One is that the variable gets isolated, like it did up here, which means that there's one possible solution. So in this case, it was that x could only equal 20 and nothing else. The other path is that the variable could disappear. And if the variable disappears, then there's 2 branches of that. And the first one is that I get a false statement. For example, like maybe I get something saying like 3 equals 10 because those numbers are not equal. Or I get a true statement like 6 equals 6 because those numbers are equal. If you get a false statement, you get no solution. And if you get a true statement, it's all real numbers, which is another way of saying infinite solutions, which is what this question is asking me to do. It's asking me to create an equation that has infinitely many solutions. So if I work backwards from this flow chart, my goal is actually to try to get a true statement. I want my variable to disappear, and I want to be able to distribute, combine, balance in order for that variable to disappear. So I can kind of work backwards on creating this equation. So maybe I want to get like 3 equals 3 because that's a true statement. Well, in order for that to happen, that means my variable on my left side of my equal sign is going to have to be equal to my variable term on my right side of my equal sign in order for them to disappear. Maybe 3 equals 3 wasn't a great choice. I'm going to pick something else. So maybe I have 2 times x plus 3. And so now if I distribute that, I would get 2x plus 6. And on this side, if I have 2x plus 6 right away, well then what's going to happen is when I balance my variables, by minusing them from both sides, 2x minus 2x is 0 and it's gone, leaving me with just a 6 on the left. And the same thing on the right, 2x minus 2x is 0, it's gone, leaving me with just a 6 on the right. And so because 6 equals 6, oops, I actually shouldn't have circled that because that's not my solution. My solution is, since it's a variable that disappeared and I got a true statement, my solution is infinite solutions or all real numbers. And in terms of the doors, that means that I could open all of the doors. And so your job on this would be to create your own linear equation. Notice how I'm only using the variable x. I do have it in 2 places, but it's still both an x, where at some point you want this variable term to match this variable term. So that way when you move them over, they completely cancel out, and you need the 2 numbers on each side of the equal sign to be the same. So now let's look at this next part. So it says, consider the equation 3 times 4 plus x equals 7x minus 2 times 2x plus 3. And it's asking me how many solutions this equation will have. And so essentially, I'm going to have to solve this equation. And so if I follow my flow chart, and this can be me showing my work, I can start by distributing. So I'm going to distribute the 3, and so I'm going to get 12 plus 3x equals 7x. Now here it's important to remember I'm distributing a negative 2. So it's going to be minus 4x minus 6, because it's a negative times a positive, which is a negative, and a negative times a positive, which is a negative. So I've distributed. Next, I'm going to combine. And so on my left, I cannot combine 12 and 3x. Those aren't like terms, so I'm just going to bring that down. And then I can combine 7x minus 4x to get 3x minus 6. Now on this one, I can see that 3x's are on both sides of my equation, so when I minus them over, they're going to cancel. That means my variable is going to disappear, which means my answer is either going to be no solution or all real numbers. And so I can continue showing this, minus 3x from both sides. That leaves me with 12 on one side and negative 6 on the other. And this time, since negative 6 and 12 are not equal, I got a false statement. That means my answer is going to be no solutions. So when it says how many solutions does this equation have, there are none. And when it asks me to show or explain how I got my answer, this would be enough of showing my work. So now let's look at our last question, consider the equation. And before I even solve this, I want to make sure I go to the answer, the question, which says how many solutions. So again, it's not necessarily asking me to solve it, it's just asking me, does it have one solution, no solution, or infinite solutions? So I'll start this by taking that first step of solving, which is to distribute. 3/8 x minus 6 equals 1/2 times 4. Well, half of 4 is 2, and minus 1/2 x. I could continue to solve this, and I'm going to balance my variables. I could add 1/2 x to both sides, right? And I could get 2 on this side minus 6, and then to add 3/8 x and 1/2 x, I would have to come off to the side and do 3/8 plus 1/2. I would need a common denominator, and so that would be 2/4. Oh, sorry, that would have been 4/8. That would have gotten me 7/8 x. But here I'm actually going to stop, because if I remember the question, which just says how many solutions does this equation have, the only way for this equation to have infinite solutions or no solutions is for the variable to have disappeared. And by adding 1/2 x to both sides, my variable did not disappear, which means that there is only going to be one solution to this equation. And the reason is because the variable did not disappear. The variable did not disappear. Sorry, I'm running out of room here. And you might have even stopped here to see that and said, well, wait a minute, it's 3/8 x on this side, and it's not 3/8 x on this side. The only way for the variable to disappear is for it to be exactly the same 3x and 3x. Or it would have had to be 3/8 x and 3/8 x, or negative 1/2 x and negative 1/2 x. If it's the same on both sides, it's going to cancel out. As soon as it's not the same, it's not going to cancel, which means it's going to get isolated, which means there's going to be one solution.